Hello, my name is Kyle Palmer, Mobile Mapping Representative for Leica Geosystems. Welcome to this overview of Leica Cyclone Pegasus Office. This is the new mobile mapping processing software set to replace Pegasus Manager, introduced as a total rethink of mobile mapping along with the new Pegasus TRK. The philosophy of this software is to have an easy-to-use, guided workflow that keeps things simple and gets data out quickly. Let's take a look. By default, Pegasus Office opens the project browser window first when the software is loaded. So let's discuss the project browser. First, I'd like to point out the storage folder. This is where projects are stored. And Cyclone Pegasus Office stores data by projects and jobs. So one project, many jobs. Here, a new path can be added by pressing this plus button. A Windows Explorer window opens, and a new folder can be navigated to and selected. The path is shown here and can be edited at any time. The different paths can be used by toggling between these two radio buttons. The projects are shown here in these cards, and in this three-dot menu, there is an option to view the metadata about the project, including the date, the unit, the coordinate system, and the project size. At any point, a thumbnail can be added for visual context using a JPEG or a PNG. A new project can also be added from scratch with the name, units, and adding a thumbnail. This is important for project planning purposes. Simply click on a project to open. The main menu can be found at the top left corner here. The project browser can be accessed. The settings, which I'll cover shortly, can also be accessed here. The project data can be accessed as well. This opens up an Explorer window where you can explore the raw data of your job or your project. This software also is paired with Leica Infinity and Novatel Inertial Explorer. So there's access to the license managers here. There's also the close and copyright button. Now let's discuss the settings menu. Under the General tab, there's a project accuracy tolerance setting, a display unit setting, and a LiDAR resolution and processing setting. This allows the user to work in a low-density point cloud until the end of the project. There are also specific Pegasus TRK sensor settings, including generating a point cloud from the two onboard SLAM scanners and a ghost filter setting, which helps with reflective surfaces. Under the Storage tab, the same menu that can be found in the project browser to navigate to project folder paths can be found here. Under the Trajectory tab, calculation and bore sighting options can be set. Under the Coordinate System tab, a projected coordinate system and units can be set. There's also a handy feature here to open Leica Infinity directly. The Optimization tab includes settings to adjust the rigor of the cloud-to-cloud solution for finding links between multiple tracks in the same job. The Finalize and Export tab includes settings on adjusting the final LGS, LAS, or E57 export files. Two noteworthy features are the Split by Scanner option and the Export SLAM Scanners option. The Split by Scanner option allows a different file to be generated for each sensor in the unit. The Export SLAM Scanners allows the TRK SLAM sensor data to be exported in an LGS, LAS, or E57 format. The first stage of the left-to-right workflow is processing. Let's review the features. The processing window shows the scan trajectories against a base map and any imported base stations. The settings panel at the right allows users to accept the RTK solution as is or make trajectory adjustments by adding base station observation data. Multiple base stations can be added to the solution. Here, the user can process the SLAM data and a cloud-to-cloud search can be initiated. The cloud-to-cloud process automatically searches the cloud for cloud-to-cloud links at the specified interval set by the user in the program settings. This process can be run again later in the workflow. An automatic control point feature searches for control point targets based on a preloaded CAD template drawing. The results can be reviewed and refined later in the workflow. On the left side of the window, there are buttons for Browse File, which opens the trajectory folder of the job, a project tree, a button for uploading control points from a CSV file, which can be reviewed on a panel at the right, and a classification panel for use in other views. The trajectory, SLAM, cloud to cloud, and automatic control points routine can be run as a batch by selecting the checkboxes and clicking the Process button at the bottom right of the window. The next stage after processing is Review and Optimize. This stage provides additional viewing modes to help refine the trajectory and control ties. A toolbar along the top contains tools for simple measurements and visualization options. One noteworthy feature is the Colorize by Track and Scan. This feature allows for a unique color to be applied to each scan in the project, allowing for a visual match. There's also a ruler for quick measurements. Each tool has a context pop-up that explains what the tool does and what it's for. This toolbar is also contextual. Different viewing modes initiate additional tools. The Views button at the bottom left has the orthometric view as the default option. This zooms out to the extent of the project. A 3D view allows the user to manipulate the point cloud in a 3D orbit using the mouse. Note the additional tools now available in the toolbar. If one of the tracks is selected, the True Slicer view can be used to review the vertical alignment between adjacent scans. The True Slicer tool creates a dynamic orthometric slice perpendicular to the trajectory line. There is a pick location feature that allows the user to go directly to an area of interest. A slice thickness slider can be used to increase the depth of the slice. A location slider for navigating the trajectory path is also available. Going back to the orthometric view, if an image sphere represented by these red circles along the trajectory path is selected, the image view option can be used. This allows the user to navigate along the trajectory path by image sphere and view each 360 image available in the project. The right-hand panel contains tools for reviewing the original trajectory as well as the cloud-to-cloud and control point results. A graphical view of each link is represented by lines between the tracks where a match is found. By hovering over the link, more detailed information can be viewed. Additional cloud-to-cloud links can be added by clicking the Cloud-to-Cloud button, prompting a new toolbar along the bottom of the viewer window. New links can automatically be detected based on redefined parameters. Manual links can also be added. In manual links, all clouds with points in the pick radius are automatically densified for refined point picking. Matching picks on features can be selected, refined, and added to the cloud-to-cloud adjustment solution here. The links can be batch remeasured to recalculate the solution with new links. The process is similar for control point pick refinement. Once the additional picks and adjustments are made, an Optimize button becomes available to recalculate the alignment solution. If the results are acceptable, the Accept button can be clicked to move on to the Finalize and Export tab. The Finalize and Export tab includes the same view options as Review and Optimize, with a new panel at the right for refining the data for export. The High Resolution checkbox densifies the data in a defined range. This can assist in limiting export file size, a desirable feature for projects where only close-in features are relevant. A colorization feature for adding RGB color values to the points is also available. The Simple Mask interface prevents unwanted color matching with the collection vehicle. The Point Cloud Classification tool allows for unsupervised classification of the points into predefined layers. These layers can be seen on the left side of the screen under the Paperclip button. Each layer can be toggled on and off. They can also be visualized at the top toolbar. An image enhancement tool is available for refining images with saturation and brightness sliders. The export box contains options for producing the desired file type. All exports by default go to an export folder in the project directory. The JPEG tool exports all of the 360-degree images. The available export formats are Leica proprietary LGS, LAS, and E57. Each has a decimation option available. The TRK dataset for Pegasus Manager option exports a backwards compatible formatted file for use in Pegasus Office's predecessor, Pegasus Manager. All of the tools can be run in a batch process, or each tool can be run separately to refine the results defined by that tool further. Simply click the Finalize button to run the selected processes. The Optional Reporting tab automatically generates a detail-rich report of the project. Project metadata, cloud-to-cloud, and control point link data is all available on this report. There are checkboxes for refining the results. Use the File Path tool for selecting a location to store the results, define the name, and set the file type, either Microsoft Word document or PDF. By default, the report is stored in the Export folder. Clicking the Report button at the bottom will export the results. Thank you for watching this overview of Cyclone Pegasus Office. Subscribe to this channel for more videos covering new releases, updates, and more information on Leica Geosystems mobile mapping solutions.